And we're back. So this is Blender 101 Part 5, and here we're going to talk a little bit about materials. So in the previous video, you learned how to make sort of a low poly sword. You learned about the sort of material preview viewport mode, viewport shading mode, which is this one, and we added some slots and some materials to those slots in order to apply different materials to our object. So in this video, we're going to do, sort of an extension of that, and we're going to start looking at how to make photorealistic materials. We're going to look at the shading tab. We're going to look at, the principled BSDF and what that is, and that's what we're going to do. We're also going to learn how to render images and use the camera, because that's going to be required for this, and also as we're sort of getting to that point where that's a good thing for you to know how to do. And then there's going to be sort of a little break before the next video, because the next sort of things that are in line are sort of big topics. We're going to talk about UV unwrapping. We're going to talk about topology, and we're also going to start working on some photorealistic assets. So we'll make a photorealistic sword. So we'll do sort of an extension of sort of building the same object, but now with new tools. You'll be able to sort of make a photorealistic version, essentially, of that asset. And we're also going to learn about multi-part objects, which that will be one. So a lot of things coming up in sort of the next few videos. So it'll probably take me a little while to make those, but I'll post these ones and then sort of get to those as I can, and we'll work towards sort of finishing out the rest of the course. So I have a general scene open here, and I'm going to go into viewport shading mode. And what we want to do is set up a scene that we can render so that we can look at our different materials, and we'll use that to sort of get an idea of what our materials look like. And so I'm just going to do this very simply by duplicating this cube a few times, and those are going to be, we're going to put our testing materials on the cube. So on this sort of default cube, I'm going to hit GZ1, and oops, I forgot to turn on screencast keys. There we go. So that was GZ1 to move the cube up in the Z axis, and now I'm just going to make a few duplicates of this. So Shift D, I'll put one over here, and actually I'll go into top view with 7 so that I can sort of just place them around like this. And actually one more trick that's going to be really useful for you here is, so by default when you do transforms on an object, it's going to do them around that point, and you can change that. There are other ways of doing it. If you look up here in the top, for example, there's this transform pivot point menu. So if you wanted to do it like around the 3D cursor or something, you could do that, but by default, operations that you're going to do to your object are going to be around this pivot. So if I scale it, right now it's scaling from the middle, and I want all of these cubes to stay anchored to the bottom of the screen because we're going to add a floor. And so in order to do that, what I'm going to do is up here, I'm going to turn on snapping. It's currently set to increment snapping. That's fine. And then what I'm going to do is I'm actually going to move that origin point. And there are two ways of doing this. The first one, don't do this because the other way is going to be better for what we're doing. But if you tab into edit mode and you select all of the verts, so you can select all of the verts in your object by hitting A, and then you hit GZ, you'll notice that the origin doesn't move. So when you're in edit mode, the origin point of the object stays where it is. And if I cancel that and I drag the object in object mode, so we've hit tab, we're no longer looking at edit mode, and I drag the object, you can see that the origin point moves with the object. And so one way that you could move the origin point is to move all of your geometry around it. The other way, which is better for what we're doing, and better in most cases, is if you hit Control period, it's going to change the transform mode so that when you apply transforms, they actually apply to the origin rather than to the object itself. So we're still in object mode here. Nothing about that has changed. But if I now try to drag this object, it's going to drag the pivot point instead of dragging the whole object. So if I hit GZ, it's going to drag the origin point down instead of dragging the whole object. And so because I have snapping on, I can just drag it to the exact bottom of the object. And then I'm going to hit Control period again to come out of that mode and turn snapping off. And so now we have an object where the origin point is at the bottom. And if I hit S to scale, it's now going to scale around that bottom origin point instead of scaling the object from the middle, so it will always stay anchored to the floor. So this is a really useful thing that you'll want to know. Anyways, that was unrelated to the topic for today, but a good thing to know. So I'm going to scale that, and let's make another duplicate, and I'm working in top view mode. So again, 7 to go into top view, and I'm just going to make a few cubes of different sizes here. And that should be good. And maybe just rotate some of these. And actually, I'm going to Shift E to put one on top here. Doesn't have to be perfect. Something like that is fine. So that is our scene. And now I'm also going to add a plane to act as the floor. So Shift A, mesh plane, and I'm just going to type S, I don't know, something big, S50. So we've got this huge plane underneath. So now we've got a floor under our objects. Cool. Now, one thing we haven't used yet is the camera, and we're going to do that now so that we can take a snapshot of our object. So if you see here, this object here, this is the camera, and if you look in the outliner on the right, you can see we can also select it here. And when you select the camera, on the right hand side under this properties panel, it adds this object data properties for the camera, and you can change all sorts of things about how the camera works. So you can add depth of field, you can change the type of perspective to orthographic, you can do a lot of sort of interesting stuff in here. But for now, all we want to do is get it in the right position so that we can use it to sort of take renders of the materials we're going to be experimenting with. So to do that, if you press 0 on your keyboard, it's going to take you into the viewport of the camera. So if you can see, for example, like the camera is looking this way, maybe from the side, it'll be a little easier to see. It's sort of looking at our objects, and that's like, we haven't moved it, so that's the default position of this camera whenever you first open the scene. If you hit 0, it's going to put your viewport camera where the camera is so that you can look through the camera. So this is currently what the camera is seeing. You can zoom in and out, but we want to move this so that it sort of, encompasses our whole scene. So everything that's inside this light sort of viewport, this sort of mini viewport here, is what's inside the camera, and everything that's dark gray is outside the camera's view and won't show when we render. So if you hit F12, it will take a render snapshot of what the camera is currently looking at. So let's do that. And you can see this is rendering slowly. It's taking a little bit of time. You can probably hear my GPU fan going wild over there because this is taking a lot of samples, and it's using that sort of photorealistic path traced renderer that we had set up in video 1. And if you don't remember that, I'm actually just going to close this. That is, if we go here to the render properties, the default render engine in here is eevee. And in the first video, we set up the properties of this render engine to use cycles. So if I leave it on eevee and hit F12, it will render with eevee, which is not the photorealistic render, and that happens much more quickly. You can see the render quality is not quite as good. It's not the path traced renderer. The shadows don't look that great, but it did happen. It did happen instantly. Whereas cycles, which in the first video we set this to be the default, this is the path traced renderer, and you'll notice that when we hit F12, it starts off quite grainy, and then over time that grain sort of disappears. And what's happening here is it's tracing light paths, and it's doing that over multiple samples. And so you can see up here in the top, we've got a sample count. It's currently at 41, 45, and it's going up. So it's taking more and more samples of this image, and the more samples that it takes, the more the noise in the image gets reduced. And this is the way that light works in the real world, is light bounces from one object and bounces from there to another, and that sort of affects the way that objects are shaded in the real world. Shaded is the wrong word, but. And so you can see that after sort of a minute of letting this sit, the number of samples is continuing to go up, and the amount of noise in the image is continuing to go down. So the more samples that you collect, the less noisy the image will be. Now, we'll talk about that in a second, but there's an immediate problem here, which is that the camera is pointing the wrong direction. So, we're not capturing all of those cubes that we want to look at. And so what we can do is, in this main viewport here, if you hit select the camera, if you hit N to open up this right hand panel, and under view we're going to select lock camera to view. And what that's going to do is, so like right now, if we move around using middle mouse or shift middle mouse, we're sort of panning around, and what we want is for the camera to follow that, so that whatever we look at, the camera is going to be also looking at that. And so the way that we do that is 0 to go into the camera view mode, and then zoom in until this is like about a good size, and then we're just going to hit lock camera to view, and we can hit N to hide that panel. And now if we drag around, this is actually moving the camera, so the camera is looking at what we are looking at. And so if I just drag this into the center here, and I hit F12, now you can see that the camera is seeing what we're seeing in the viewport, and so this is what we want. And if I close that, I'm actually going to go, if you hit 0, so the camera is positioned correctly now. If you hit 0, what will happen is it will unlock your viewport from the camera, essentially. So we're no longer moving the camera when we move around. So if we're in front view or top view or sort of this perspective view, we're not moving the camera around. But if we hit 0, then we can immediately go back to repositioning the camera. So this is the most convenient way for you to place the camera in your scene. So we've got our camera placed in the scene. We have our render engine set to cycles. It's using our GPU to compute. And one of the things I want to change here is the render samples. So you saw when I hit F12 to open this, it's taking a while and it's doing a lot of samples. And the reason for that is because the default value for max samples is 4096 with a very low noise threshold. So what we're going to do is, I'm actually just going to turn noise threshold off. So you can either set this noise threshold, and what it'll do is when it essentially has reduced the noise by taking enough samples, it'll stop. And you can set that to be a value by default in the viewport, it's 0.1, and by default in the render, it's 0.01. And what I mean in the viewport is this viewport shading tab. So if you go and you change the render preview mode to viewport shading up here in the top right, it will preview these cubes, using that noise threshold that we have set for viewport here in the render properties under sampling. And you'll notice here that only rendered for like a little bit, and if I move the viewport again, it'll re-render that, but it's much faster than the one that was coming out of the render, and that's because this noise threshold here is set to a much more stringent value for the render than it is for the viewport by default. So I'm going to set that to 0.1. So, and it is going to leave some noise here, but we have the denoiser turned on, so it should denoise. But this is now essentially going to do the same number of samples in the render as it would in the viewport, so it's not going to take too long. So it's rendering, and it should stop shortly. And there we go, it stopped at 60 samples, and then it did a denoising pass because we have the denoiser turned on, and as a result we have a very clean render, and it took not that long. And how long this takes to render will depend on your system. So if you have an RTX 4090 or some super killer graphics card, this will render very quickly. And if you've got a graphics card from the early 2000s, then it won't. All right, so that's the camera, and that's rendering using cycles. Let's now go ahead and start making some materials. So I'm just going to go back to material preview mode here for a second. And what I want to do is add materials to each of these objects. So this cube over here on, actually maybe this one here in the center, we're just going to leave as default. This is sort of the central cube will just stay like white, and then we're going to add materials to each of these other ones. And if you remember, we could create a slot for this object and then create a material to go into that slot. And that's what we want to do. So if I just add a new material, it's going to add a slot automatically, and it's going to put that new material in the first slot. So here's our first material in the first slot, and I'm going to call this plastic dull red. And now on this one here on the back right, I'm going to call this steel, and I'm going to add a material to this one up top as well, and we're going to call it plastic green shiny. So we're going to have a couple of different types of plastic here, and then we're going to let's add one more here. Let's add like a brass dull. All right, so let's make those materials. So here on the right, I showed you last time in the previous video that we have this surface panel here when we have this material selected that shows you all of the properties of this material. And what this is it's actually the principled BSDF output from the shading tab. So what is a BSDF? A BSDF is a bidirectional scattering distribution function, which essentially is a shading model that tells the renderer how light in the scene should bounce off this object and what it should look like. So in Blender, the principled BSDF is based on the Disney principled model, which is the PBR shader. PBR stands for physically based rendering, and essentially what that means is this is using the physical properties of the object. So we tell this object, what are the properties of this, or we tell this material, what are the properties of this material if it were like a physical material in the world, and it uses that in order to calculate the shading that's required to make that material look real. And this is the same shading model that's used in most sort of big name 3D rendering applications today. So Unreal Engine, Substance Painter, all of these use the Disney principled model. And so Blender does as well. And so we're going to be using essentially the same methods for creating materials that you would use if you were to create a material inside one of those other applications. So let's go ahead and look at the shading tab. So these details here, if you remember, I told you this is actually just a summary of what's in the shading tab. So with this object selected, so this is our plastic dull red material on our cube here. Let's go up here to the top and click on shading, and that's going to open the shading panel. And there are a couple of things in here. You can see that we've got a lot more windows. The two most important ones to focus on for now are we've got the viewport on the top that shows us the object that we've got selected, and over here on the right I'm just going to click on material properties. It's a good idea to keep that open so that you know which material you're looking at. And down here in the bottom, that is that material. So this summary of information here on the right under the surface panel, this is the output that's coming out of this principled BSDF is going into that surface. And so this data here in this principled BSDF is that information that's over here on the right. So if I change, for example, if I click on this base color and change it, you can see here it's also changing over here on the right. And so this is our first introduction to nodes in Blender. There are a lot of material nodes in Blender and also geometry nodes, which are new that we'll probably talk about, sort of at a later date. But for now, we're just going to look at material nodes. And you can create very realistic looking materials using nodes in Blender simply by creating nodes and connecting them to sort of be output here as the material output for your surface. Most of the time, you're going to be using this principled BSDF, but I also want to point out that it is not the only BSDF that exists in Blender. If you hit Shift A and then search for BSDF, you'll find that we have quite a few. So if I grab, for example, a glass BSDF and put it here and plug this into the surface output of this material instead of the principled BSDF, you can see that changes it over here on the right. So that's now that summary of this surface is now reflecting that we have a glass BSDF being output here instead. And if I click on rendered view, you can see that this is now a glass material being applied to the surface of this object. So anyways, let's undo that, and I'm just going to stay in material preview mode and make sure that the principled BSDF is connected to the surface output on that material. So let's start making our materials. So even though there are a lot of properties inside this principled BSDF, there are really only a small number that you care about. Some of these, like specular, you're never going to want to change specular if you're doing physically based rendering, which for photorealistic workflows you are. And some of these other things like index of refraction, you'll need that if you want to make like glass or water, but just for sort of opaque materials, you don't need to worry about touching that right now. And some of these other things will be like normal inputs we'll be learning about in sort of later videos. So for now, the three that I want you to focus on are base color, metallic, and roughness. And these are really the biggest ones that you need to know in order to create materials. So the base color is what it sounds like, is the color, the underlying color of the material itself. And so this one here, this first cube that I had selected, we have plastic dull red is the material that I created here. So I'm going to change the base color to sort of maybe a reddish, dark reddish color. And how do we make sort of a plastic material? Well, a plastic material is non-metallic, so we're going to leave this at 0. And metallic, generally speaking, you only need to have values of 0 or 1. And what the metallic slider is doing is essentially saying, is this a dielectric material or not? And metals, for metals, you would turn it to 1. For non-metals, you would turn it to 0. So even though it is a slider and you can make some sort of semi-metallic materials, generally speaking, most materials are either dielectric or they're not. And so for plastic, we're going to leave metallic at 0. And then for this roughness here, the roughness is essentially how shiny the surface is. And if you think about it like sort of on a microscopic scale, what makes a surface highly reflective is that the surface is very, very smooth. And so if you have a low roughness, it will be more shiny. And so if we turn the roughness all the way down, you can see that this is now a shiny cube. And if you have a high roughness amount, it is going to be very, very dull. So you can now see that this is a very dull cube. And so for plastic dull red, I'm actually just going to leave the roughness around 0.5, and something like that should be fine. Now let's click on this second cube, which is steel. And so steel is going to be a metallic material. So we're going to slide the metallic all the way to 1. And then for the base color, I'm just going to give it sort of like a gray color here. And if we wanted this to be like a polished metal, like something that is very, very smooth, what we could do is turn the roughness all the way down to 0. And I'm actually going to do that because I think that it'll be a good demonstration. You don't always want perfectly smooth metals. Not all metals in the world look like completely reflective mirrors, but that'll work for us for now. And then we also have this plastic green shiny. That's this cube here at the top. And so I'm going to make the base color for this into a green, maybe a bit of a darker green. And then I'm going to, again, it's plastic, so I'm going to leave the metallic at 0. And for the roughness, because I want it to be shiny, it's going to be very smooth, so it's not going to be rough at all. So I'm going to turn the roughness again down to 0. And then we have brass dull. That's this 4th cube over here on the left. So again, for base color, let's just give it sort of a yellowy color. And it's metallic, so we're going to turn metallic up to 1. But in this case, I'm not going to make it reflective because this should be a dull brass. And we could turn the roughness down to 0 if we wanted like a reflective brass, like a completely smooth one. But for this, just so that we have some variety, I'm going to leave the roughness maybe around like 0.15 something, so it's not completely smooth, but it is fairly smooth. And that's essentially the basics of how you create materials just using the principle BSDF. We are going to talk a little bit more about how to do procedural materials using nodes, and that's going to be a really fun video at some point, so that we can learn how to make some very realistic materials using nodes. But for now, I'm going to hit F12 to render this, and we'll see what we've got. So you can see we've got the that sort of steel cube in the back is reflecting this red cube because it's pretty shiny. You can see up here in the top we've also got this green plastic that's shiny, and we've got that sort of dull brass cube in the back, and they all look sort of pretty much how they should look. All right, so that's a quick intro to the principle BSDF, the shading tab, and the camera. So there's going to be a little break while I make sort of the next videos in the series, but we're going to talk in a lot more detail about materials and start making some sort of photorealistic assets and learning about normal maps and displacement and all of those sort of fun things. So that's it for now.